Hello, my name is Terry Large, and I'm just a normal guy, a guy with couple college degrees, probably no more um, competent to talk about global warming and climate change than the science guy. So I thought I would put my 2 cents down here and just talk a little bit about what I think we can do to come to some kind of a consensus for those of us that are people that will at least listen and think about how we can measure this stuff and decide how much CO2 is right, how much is good, what's best for the earth and our environment. No one talks about that. So today I'd like to spend a few minutes, more than I normally do, just talking about this. Um, so I wanted to find out how much CO2 really is the right amount. Let me preface this by saying I'm not a global warming denier. I'm a natural climate variable believer. Climate has variability. It always has, it always will, before people and after we're gone. We had ice ages before mankind ever set a foot on this earth, and they receded and came back multiple times. There was no man made global warming at all. So the idea that all of a sudden we've changed the climate, well, the climate's always changed, and it always will change. It's a very cyclical, variable process that has so many variables to create the climate that we have that to say that CO2 is the one is, when you think about it, really kind of insane. If not insane, inane. So I'm going to show you some grids here. The first grid is just 10 by 10. There's 100 cells in this grid. Each cell is 1%. So let's look at the first one. The chemical, the molecule, the atom that's in the atmosphere the most, atom, is nitrogen, right at 78%. So I've highlighted 78 of these little boxes. Actually, it's a tiny bit more, like 78.9 or 09, I forgot which one. And then and nitrogen, by the way, is an inert gas that if we didn't have it, we'd either have too much CO2 or we'd have too much oxygen. And both of them would not be good for us. We would not survive with too much oxygen. Like if the planet was 100% oxygen tomorrow, we would not do well, even though we breathe oxygen. The next grid is oxygen. This is 21% of the atmosphere. Obviously, we need oxygen. Not too much. 21% is probably really good, and it could probably go up a few percent here and there. You don't want to have too much oxygen. So the next gas that's the most abundant in the atmosphere is argon. It's not a greenhouse gas, but it's argon. And it's not even 1%. It's 0.93%. Now we come to CO2. And when we have CO2, it was really difficult for me to draw this because it's 0.4 of 1%. It's 0.4 of one of these cells. That's an amazing fact that people sometimes, we talk about numbers and stuff, and unless you see it visually, it's really hard to imagine how little CO2 is in the atmosphere and how good it does. So, and then water vapor is either 0.4%, depending on where you are in the atmosphere or on sea level, or up to 1%. So there's much more water vapor in the air, in the atmosphere, than there is CO2. And what do you think really might affect our weather? I know on a hot day, I prefer to find shade, maybe shade provided by a cloud, which is nothing but water vapor. And And I feel cooler. The sun radiation is not as intense. My point being is that what do we think affects climate more and weather more? Maybe water vapor is a lot more effective effect on climate than does any other things that we've listed here in this slide. Nitrogen is not considered a greenhouse gas, nor is oxygen. If we talk about what CO2 does, CO2 creates life on Earth. Without CO2, we would not have plants. Plants need CO2 in their photosynthesis process. And we also need oxygen for us. Now, isn't it interesting that the plants and the animals are codependent in this process? We inhale, we use oxygen, and we exhale carbon dioxide. We exhale more carbon dioxide than we inhale. Isn't that good that we have this relationship with plants and animals? Without that, there would be no life. We need oxygen and we need CO2. So to get rid of CO2 haphazardly could be very detrimental to plants. Let's think of a way that we can figure out how much CO2 would be good. Now, a greenhouse, commercial greenhouses, they actually pump in CO2 to the greenhouse. Not in an attempt to increase the temperature, but to actually increase the CO2 because the plants need CO2. And if they have more CO2, they become more sturdy, they become more tolerant, more resistant to effects like drought, insects, and they produce more fruit. And when I say fruit, I mean they produce more of what they are there for, whether it's grains or actual fruit or vegetables or pine cones. So they produce more. That's why the greenhouses actually pump in CO2. They get more in return. More quantity, better fruit, better survivability. Now, how much do they pump in? What do they do? Well, looking at the charts, we'd have to fill in 8/10 of one of them, one of the cells, or two of them. Now, this equates to 800 parts per million on the low end and 2,000 parts per million on the upper end. So, to say that we need less CO2 because it's driving heat, when I would suggest to you that it's not coming, has nothing to do with CO2. It has to do with the water vapor in the air. The heat of the sun evaporates water, it goes into the atmosphere and forms clouds. And along with that, there may be a slight increase in CO2, but the vast majority of it is water vapor in the clouds. And the clouds provide shade, which in turn cools the planet off and causes less evaporation because the planet is cooler and there's more clouds over the oceans. And so it's a very cyclical thing. The sun heats up the water, we get more clouds. The clouds produce rain. The clouds also, which cools things off, and also they block the sun. They block the heat. So the earth then cools off a little bit, and this cycle just keeps going on and on. So, so what do we know about plants, and how much less can they take? Well, at 180 parts per million, and that's not very much less than what they want us to cut back on. A little bit more than half. Plants die. They can't survive. And at approximately, depending on the plant, 350 parts per million, plants become stressed and start producing less fruit. They become less drought tolerant. They become less resistant to insects. So if we go down too far, we can actually kill the plants. And if we go up, what's the result? We have more fruit. We have better plants, plants that are going to survive, plants that we can consume for energy, the energy that has come from the sun. So I would like us to say, how do we, instead of all these different models that we have, and that, don't get me wrong, I like math, but given all these models that we have that are highly suspect and really don't really work on a small scale after a couple of weeks, maybe even less than that. So what can we do? Why don't we have an experiment by real scientists, not me, not the science guy, but real scientists that would actually measure the optimal amount of CO2. Now, in a greenhouse, how much does the plant produce? How long does it live? How sturdy is it? How resistant is it? Now, granted that there's variability in that because different plants require different amounts of CO2, but we can come up with some range where that, okay, this is a good range for most of the plants, and there's this range that we can go, a plus or minus 500 parts per million, let's say, whatever that is. I mean, the range may be 1,000 to 1,500. I don't know, but we should find that out instead of just sitting here saying we need to reduce CO2 and it's going to kill the world. And well, it's not going to kill the world. We need more CO2. More CO2 will have more plants growing. If we go too far with this stuff and we start killing off plants because we're reducing CO2 and we start making plants more susceptible to disease and drought, at what point in the famine that would surely result are the people that are the greenhouse people that believe in this, what are they going to say to those people as they're laying there dying because they have no food to eat? So these are my thoughts, and I hope they're reasonable, and I hope that people may consider promoting this idea. I mean, if you feel the way I feel, maybe we should send a letter to our congressman or senator and say, hey, why don't we do this? Why don't we do this greenhouse study? Anyway, those are my thoughts, and I appreciate your time.